Okay, so we're continuing with part B of this lecture. I'm not sure if we will have time to go through the whole lecture this time. I think it's better to stop and discuss rather than just to push too much information to you. And the good news are that next lecture is not super important. Actually, it's because I think this lecture is the programming lecture. The next and lesson number 5 is fancy stuff, which is fun and nice, but it's not as important as getting this right. So it's better to take it slowly and then just push everything that we don't fit into this lecture onto the next ones.
So if we don't finish, if we don't finish today, then we will continue next week.
Yes.
With this lecture. Mm-hmm.
Exactly. Or after this lecture, I think we will only do things that you want me to talk about. Yeah. So you can decide. Mm-hmm. And if you don't have anything special, then I can use like lectures from previous courses. Okay, so now we talked a lot about for loops, the different kinds of for loop, and made them really complicated and so on. And for loops are good if you know how many times you want to loop, but sometimes you don't know. And then you use another type of loop, which is the while loop. And here's an example of that. The loop starts with while and ends with an end. So in this example we are creating a variable called correct guess, which is a random number between 0 and 9. You can also do this in other ways. I don't know why I choose this particular way. Perhaps it's easier to use Randi, but anyway, we've got a random number as the correct number. And then we set the current answer to something that is not possible, not within 0 to 9, -1, for example. And then we loop. We start the loop by checking, is the current guess equal, or actually, if the current guess isn't equal to the correct guess, then we should do something. And what are we doing? Well, we're asking the subject or the user to answer this question. Guess a number between 0 and 9. And then you have to type on your keyboard, and current guess becomes what you typed. Then the loop ends, so it goes back and checks.
So this would be useful to create stimuli, for example?
This could be used for creating stimuli. We can cut and paste everything into this lecture C. And if we run it, it says guess a number between 0 and 9. Actually, perhaps people don't really see it. Okay, what should I type?
3.
10.
3, 10. Eduardo?
8.
5.
And then,
Yay!
8! Lykke is the smartest.
Yes! Oh, finally, here's my proof.
Yes.
so if you wanted it to say, when you said 10, if you wanted to say like, oh, this is out of bounds or something, what would you do then? Can you stop people from doing something else than what's
Yes,
not? Yeah.
you can do that. But then you have to use a conditional statement.
Okay.
So let's see, it's probably just a few slides away.
Alright, if they say this, wrong, try again.
Yeah, here's another example. If you want to input data and you want to continue inputting data until you're done. So in this example, you can enter an IQ number until you press enter. And it will store the number you entered. I'll show you what it looks like. Okay, 100. Okay, and when we're done, we can see that we've got this data in the workspace.
For the first one, when you make your guesses, would it be very complicated to send that so that you enter the information in not in Matlab? So for example, if you use it to make a stimuli and you want people to sit in the lab and answer questions, then you would like to do that on some random interface or something, or would it be really messy? You might want them to do it within Matlab, but that feels kind of weird.
No, I think often, especially if you want reaction times and so on, it's better to use presentation or ePrime or dedicated stimulus software.
Yeah.
When it comes to easy things like this, it's fine. But then it's often not very difficult to read the data from other sources into Matlab. So it actually depends.
Yeah.
Sometimes I make the stimuli within Matlab and present it and let the users rate the stimuli on the fly. It's very good if you want to have like adapted stimuli that adapts to the performance. Then it's good. Or if you're doing biofeedback things, probably should make sense to have everything within the same programming language.
I didn't understand the correct guess equals -1. Why did you write that?
Why did I do that?
Yeah,
Well-
current guess.
Yeah, because if I would, if I didn't define it, it wouldn't know what current guess is here. So then we would get an error. But if I, for example, defined it to 5 or something, then it could happen that the correct guess also is 5. And then it would never enter the loop. It would just continue and output good job. But any number here is that is outside 0 to 9 is fine. So we could use infinity, for example. Or not a number, perhaps.
And why the correct guess is 5?
Because the correct guess is a random number.
Yeah.
Between
It
zero-
differs.
It's a random.
Yeah.
Okay.
So we get a random number here.
Okay.
So the next time I run, it will not be.
It
Was
will
it?
not be 5.
No, exactly.
Okay.
But I wonder what happens if we do not a number. Let's try.
But then if you mistaken it put like, I don't know, V, then it would.
Let's see. No, it wasn't 5 anymore.
6.
6 and.
What happens if you put a letter?
Yeah, let's see what happens. get some error. Okay.
Okay.
So, okay, so that was actually all about while loops. It's a loop, but instead of changing the number according to a vector, you have a conditional statement. So while this statement is true, it will run the loop. And now we're getting into these small, nice things. If you use type continue, it will skip the rest of the loop, the rest of the code within the loop, and start over from the beginning. That's good. I use it in conjunction with if statements.
It's not the same as the else.
No, it's not. When you need it, you will remember that, in this case it would be really nice if I just started over with the next one. And then you, at the back of your head, you know, okay, there's a function. I don't remember what it was, but I'll find it. And the same thing with break. It will just stop the loop regardless of where in the loop you are. So if you have a loop that is 5,000 times, you can stop after 500. Actually, I haven't thought about this before. What was the example? 5, 4, 3? This one. That created an error when it exceeds the array bounds. So in this example, it could be nice to have something like if I is larger than the number of elements in A, then we break the loop. Because we know that once I is larger than, once we're outside of the bounds, we might just as well quit.
Then it works.
This should work. And it works. So this is it's a matter of programming style, how you do this. I mean, another way of doing this would be,
So you could have also written continue, even if there's no continuation, you can just write continue. That will
Yeah.
do the loop.
if we do like this, you will see the difference. Now it outputs 11, but it never outputs the error. If you type continue here instead of break, it will continue to loop all the way.
Okay, so that's different.
Yeah, it's slightly different depending on what you want to do before you continue. So for example, sometimes you want to do something with all your subjects, get their group belonging or something, but skip analysis if they don't have enough data. Something like that.
But the continue, is that also dependent on where it is, that it's on the third line, so if you put last, then it would get an error?
Yeah, but it would still loop 1,000 times.
Okay.
But we don't see it. That's why I moved it, so that you could see what is the difference. Right? But of course, you can also do this like because you can count the number of elements in A, and then this becomes unnecessary.
Yeah.
And this is flow control in a nutshell. This is how you control what is happening. And you can do it in many ways, even though it's sort of the same. But using different tools to direct the data to get hopefully what you want in the end. And knowing, it's a matter of programming style, how you do this, what makes sense at each particular situation.
Usually when you start analyzing your data, you have a set of scripts already
Yeah.
ready-made, and then you use that one, and then you adjust by putting whatever you want in the middle. Is that how it works for you?
Sometimes, but I'm often the person making the script, so I often start from scratch.
Ah, okay.
Quite often.
Quite often.
Yeah.
Kan du ta tillbaka den eller sånt där?
Det gör jag, precis. Tack för idag, Micke.
Ja, okej.
Lycka till med studentragnet.
Ja, hoppas de nappar.
Det gör de nog.
Det tror jag med. Vi utgår från det nu så får vi.
Ja, ha det gott.
Cheers.
And we continue with conditional statements. I think we covered loops pretty well. So we can continue with the conditional statements. And conditional statements checks if something is true or not. So this is pure logic.
I tried to use this for my table and I failed miserably.
Yeah, for your table. Okay.
Yeah.
You can have a look at it afterwards.
Yeah,
Or we
I did it in the command window, so it's very messy to backtrack.
Okay.
Unfortunately.
So let's have a look at this and see if you solved it.
Yeah, eureka
afterwards.
moment.
Yes, that would be really good. So what I usually do is I'm checking, comparing things, and comparing if a variable is equal to another. And to do that, I use two equal signs and not the simple single equal sign, because that means that we're assigning something to, we're setting the first variable to the second. But if we want to compare them, it's a double. Or to check if it's not equal to the other one, which is tilde and equals. If it's more or less than, or if two strings are equal, like in the examples we had where we tried to find subjects belonging to a particular group. Then we use styrkump, and I'm often checking if a variable is a certain type, and is none is what is most important for me, because I have a lot of missing data in my data, but I don't think that's the case for you necessarily. And is empty is also really good to use sometimes. And the conditional statement checks if this comparison is true or not. No, if it's true, then we should do one block of code. And optionally, if you want, do something else if it's not true. But many times you just don't do anything if you don't do this other thing. So I think we'll start with that. Just check if something is true and then do something. And we have two types of possibilities here. the if statement, which is most important and which is available in all programming languages that I know of. And then we have a switch statement, which is almost a convenience function to if. Right? It's a special case if you have several different options. And I won't talk about it in this course because you can use the if statement to get the exact same behavior. So to make it less complicated, to keep it simple, I'm only talking about if statements in this course. And actually that's something that I do when I program. I don't use switch statements unless I'm copying code from someone else. I actually did that this morning. So for first time for a very long time I used a switch. But anyway, here's the first example of if. And it goes like this. We create a random number between 0 and 10. We output this number so that we know what number it is. And here's the if statement. So the if statement starts here and the block of code that it executes ends here. So after the if we have the logical statement. A is bigger than 5. So that's either true or false. And if it's true, then we're supposed to output that it's greater than 5. Otherwise it won't do anything. We'll just continue down here and it's empty. So we can see what happens. We've got a number that is 4.7. It's smaller than 5, so it doesn't output anything. And now when A is larger than 5, it outputs greater than 5. And this is sort of the answer to your question. Can we check if the user enters something that is out of bounds? Well, here's that example. If current guess is larger than 9, then we write something. Your guess is too large. Keep within 0 to 9. Please. Then we end the if statement.
And if you want multiple, so if you want if it's larger than the 9 or smaller than 0, can you put or in the same, or do you have to do two different?
You can do that. And the or operator is it looks like this. This is what you wanted, right?
Yeah, exactly.
And now it says, well, you should use 2 because it's a conditional statement. But I think this should work. Yeah. It works.
Yes.
Or if it's not a number, anyone.
Yeah.
Tricked it.
Ooh. Yep. What happens if we...
Can you but also just like 0 to 9?
What?
Can you enter like a vector? Oh yeah, exactly. Yeah.
Okay, so we can cheat a bit. And I think here's the very important extension of the if statement. So if a is larger than 5, we do this. Otherwise, we should do something else. Then you have the keyword else. So in this case, the conditional statement has 2 blocks of code. One thing that happens if the statement is true, and one thing that happens if it's false. So that's nice. Here's an example where you remember this one, we input IQ numbers. If the IQ is larger than 150, we think that that's really unlikely, and we don't want to add these super clever participants to our study. So it says, oh, that's unlikely, I won't add. And if the answer is larger than 200, it says, well, that's absurd, I will stop doing this. We can try this. You see that I'm looping, using a loop, and a conditional statement that breaks the code, or breaks the loop. I have, actually I didn't say anything about this. Else if. It's making a new conditional statement that will continue the loop without adding the subject. So this is a pretty complicated structure of loops and conditional statements.
So they continue, so then it doesn't count that one, but it continues to execute the loop.
Exactly.
Yeah.
We can try and see what happens. 90, fine. 130, fine. 160, won't add, but then we add 101, 104, and then we have 244. So when it's too high, it just breaks, and you can see that we only have the values that are within our wanted range.
And if you would have entered a negative number, it wouldn't have broken the loop as well, since then it's outside of the while.
No, it would have added that value, because we didn't check if values were too low.
Oh, yeah, right, it's above, so yeah. Okay, yeah.
But of course, it's not if it's greater than 0.
Yeah, but,
Yeah.
yeah, but,
Yeah, exactly. It should stop.
yeah, exactly. Yeah, exactly. Then it should stop,
Yeah.
but then it won't say anything. It will just
No.
stop.
But if we have an IQ of like 5,
Okay.
it
You would add.
it would accept it. Yeah.
And then you can put greater than 50, 60.
Exactly. And then you just add more conditions,
Yeah.
conditional statements. And that's it. If you get this, you can just use these things to make really large and complex programs. So from now on, we can concentrate on getting faster and more efficient on doing these 3 things. Changing variables, looping and checking, and visualizing. And that's why this is my favorite lecture.
Yeah.
we're done.
Yeah, this is the core, and
Yeah,
if you know the core of the whole thing, then you can
then
then
it
expand.
expands. But it's harder than it sounds.
Oh, yeah.
This sounds really easy.
Of course.
So, as I said before, the next lectures we can talk about whatever we want to, but these are some things that people often want to talk about, like getting data from other places, from text files, from the web, or I don't know. I think I'll concentrate on text files and data files, the kind of data files that you actually have. Statistics, it's an interesting part. Or structuring using functions and when to break up your code and so on. And more plotting and visualizing options. I think we touched upon most things. But we can talk about it more anyway, so that you can get really like print quality figures out from your scripts. And graphical user interfaces is something that I've talked about also previously. Okay, so the last part, debugging, which I said was like the noble art of debugging. I think within these examples, I used my most common way of debugging. It's visualizing what's in my variable when I loop. Is it what I expect? Because it's often not. When something is wrong, the data in the loop is not what I expect. And then I know, okay, it's in this loop, it's this part of the code that I have to check. So that's actually bullet number 2. But if you get an error message, of course, that's the easiest way to start to find the problem. So if you don't get it from the error message, insert statements into your code to give you feedback on what's going on. So you can answer questions like, what happened right before your error? Because often it says, this variable is out of bounds, but it doesn't tell you how much or so on. It only says like this variable. Then I add one line just before the error with a disk. So I get to see the value that's causing the problem. But of course, if you have a program with which is really super big, it can be difficult to know exactly where to put this piece of code. So it's important to be able to localize it. If I don't know, often I know that it should be one part of code, and then I display the letter A at the top, then after a few lines B, C, D, E, F, and then I run the program and I see how far do I get. And if it stops at E, I know that somewhere between E and F, there is my problem. So that's a very simple technique. And by using sub-functions, it's quite easy to just add an output at the start of the function, so that you know that you're actually entering this function. This now in function blah blah blah. And if you see it in the command window, you know that, oh, yeah, it entered the function directly. Then if you are unsure, of course at the end you can also leaving the function. So you can visualize how Matlab works through your code. Let's see what's... And the good thing is that Matlab also has a built-in debugger, which has the possibility to add breakpoints in the code. So when Matlab reaches one of these breakpoints, it will stop and pause the program and say that Matlab is in debugging mode. That's shown by a K. I don't remember why. And it will stay in this mode until you type db quit. There are also some buttons here, but I can show you what it looks like if we take this example. If we click on these small lines at the side of the code to the left, it will stop. So now I got 2 breakpoints, one at line 9 and one at line 13. And if we run this code, you'll see it will get to line number 4 and request an IQ. What should I write? 100. And then it stops at line number 13, because it never enters the else loop, so it never reaches this line, but it gets to line 13 and stops. And now I can see all the variables that are in this function, so I can see the state of these variables. And if you have the workspace open here in the layout, then you can double click on these structures to get into what's going on. So if you're old-fashioned like me, you visualize by entering statements in the code itself, or you enable these breakpoints to temporarily halt see what's happening from within debugging. And you can see here in the editor you have you'll see a green line where Matlab is right now, and you can tell it to, okay, go 1 line down. See the green arrow, continue down, and then it loops up again. And you can stop debugging if you want to. Stop debugging. And that's it for today. Functions to know for the next time: the for loop, the end, while, if, else, continue, break, display, mean, input, abs, and randy. And then, yeah, you're done. And you will get, I don't know how many assignments this is, because it's divided into 3 parts. Well, except this one. Assignment 3A. The goal is to start using your real data so that this becomes meaningful for you. So you should try to bring real data from one of your experiments as a text file or as a mat file or whatever, as a spreadsheet, whatever comes out from your machine. and formulate a task goal that is suitable as an exam assignment. From now on, we'll shift focus to your own research. Assignment 3b. The goal is to understand loops. And you get to try two things. First this, and then this. And you get to write in text, describe what happened in the second block of code. You can actually do it, you can just add comments here and explain what it's doing. And in the end, write another comment where you say what you think that this is. What happened? And why do we want to do something like this? Assignment 3. C. To master loops. And we're pretending that we have two groups with one value from each subject, group A and group B. Group A have 12 subjects in it, and group B have 9. And now we want to create 1,000 new groups. 1,000 new A groups and 1,000 new B groups by using the data that we already have. So you pull them together like this, and then you draw you make a loop that loops 1,000 times, and you pull 12 random numbers out of this to create the new group A, and pull 9 random numbers out of this for the other.
1,000
1,000 times.
for each group.
Yeah.
So 1,000 times random numbers of 12 random numbers at 1,000 times.
Yes.
9 random numbers.
1,000 times. And you need to store these new groups in a variable.
But it should be that the 1,000 new A groups, that's one variable with 1,000 A persons or subgroups, or it's not one group with 1,000 entries of 12. Or is it the same?
You can do it in many different ways, but at the end I think the easiest way is to create a matrix with 1,000 rows
Yeah.
and 12 columns for group A, because then they
Exactly.
would sort of represent all the 1,000 new groups, and a 1,000 times 9 matrix for the group B. And to get this you need to loop. And once you have this, you can continue with the last slide, assignment 3D. So if 3C was to master loops, which was the first topic of this lecture, assignment 3D is the if statement, which is the second topic. And it's a lot of text, but I want you to calculate the difference of means between group A and group B and store it so that you know how big was the difference in the original groups. And I want you to loop through your 1,000 groups and make this comparison again. What's the difference in means?
For every of the 1,000 or
Yes.
in total? For every?
For every of the 1,000, I want to get a new difference, new mean value of each group and the difference between these. And I want to know how many times was the difference larger than the original difference and how many times less. And calculate the percentage. How many times was it different bigger? So in the end, you get a percent score looking something like this. How many times was the difference larger divided by the total number of comparisons?
That's a hard one.
If you get this right, this is the last assignment. So then you'll pass the course, more or less.
Nice.
And I think that's end for this